Everything all right. And I hope you can see my screen as well.
Yes, sir.
Okay, thank you. Okay, so once again, good evening, everyone. I welcome you all to today's session on classes, objects, constructors, and modifiers, which happen to be a core introduction to object-oriented programming. I am James Adu, and I'll be your tutor for today. Before we start, let's recap on data types, which we treated, I think, a few sessions ago, and do a little diving into some core aspects of it, which will help us understand today's class a bit better. If you, if there are some technical issues on your side, you can just let us know, and we would assist you. Like if you can't see my screen or something. Okay. Um, I think we learned some sessions ago about data types. We learned of string, int, double, boolean, char, and the rest. So these data types happen to be categorized into two. We have the primitive data types and we have the reference data types. So what you learned happen to be the primitive types, and these are they are listed here. We have byte, we have short, int, long, float, double, boolean, and also char. Those are the primitive data types. You have worked with these over the previous sessions, and also you are quite familiar with some of these. And also these primitive data types, what they are is they hold the data we assign to these variables that of these types are stored directly in the variable. Yeah, let me read from the slide to help you. It says these primitive data types, they hold data within their own memory space, which means the variable of these types directly contain the values they are assigned. So if I create a variable of type int, I call it I, and I assign it a value of 100. So int I equal to 100. What I'm saying is I'm instructing the computer to reserve a memory space in the RAM, and then in that memory space, it should put the value 100 in there. So that it does that, and then it returns that address. Okay, it does that, and it returns that memory address directly to a variable. So our variable is directly mapped to the value it's storing. That's how the primitive types we have come to know are stored in memory when the program is being run. So this, for instance, the memory space will hold 100, and the address of that memory space of that the address of that particular data in memory, it will be put in our variable I. If something is not clear, you can just ask, and then we can help you. And yeah, the other type is the non-primitive types. They're also called reference types. Let me go back here. The primitive types are also known as value types. Okay, and then we have the non-primitive types, which are also called the reference types. They are the strings, the arrays we have come to learn. And there's one new one you probably have not seen yet. That's called a class. We will learn more on what a class is in today's class. So we've worked with strings in previous sessions. We've worked with arrays. Those two are non-primitive types. They are all reference types. So let's get to know what they are. Non-primitive types, they are unlike the value types. These ones, they don't hold the value directly. What happens is when you, let's take this sample code here, string s equal to hello world. We are familiar with something like this. So what happens here is when you create a variable that's of type, a variable that's a reference type, the value is stored in a memory space. See the diagram here. The value hello world is stored in memory, and that particular address space, that particular address of that data is stored in another memory space. Okay, so when you create a reference type, two spaces are reserved in memory. Let's get that down. Two spaces are reserved in memory. The first space stores the actual sorry the first space stores the actual data, and then the address of that space that's storing the data is kept in the second reserved memory space. Okay, and that reserved memory space's address is what is returned to our variable. So our variable is not directly tied to the value, but rather it is tied to some other memory space that's holding the reference to our value. I don't know if that's clear. I hope it is actually, because this is important for subsequent understanding of certain aspects of the program. Yeah. You were saying something. Hello? Okay, let's continue then. So let me recap this particular part. Unlike value types, a reference type does not store its value directly. Instead, it stores the address where the value is being stored. Okay. In other words, a reference type contains a pointer to another memory location that's holding the actual data. So hello world is inside some memory location, and then its address is stored in another memory location, and that memory location's address is what's actually stored in our variable. So it's storing a reference to the data, but not the data itself, hence its name, reference type. So I hope that's clear. Okay. And reference types, they are usually created using a keyword called new, the new keyword. So an example is taking this particular expression we have up here, string s equal to hello world. We are familiar with that. That particular expression can be rewritten as string s equal to new string, and you put the value inside the quotes. Okay, so these are the same. You can write string s equal to hello world, or you can write string s equal to new string hello world. So that's how reference types are instantiated. If you want to create a variable that's that's whose type is a reference type, that's how you do it. Use new something something. But string has a shortcut, and that's what we are used to. String s equal to hello world. All the other reference types, you'd have to use the new keyword to create a new instance of it. If you have any question, you can raise your hands, and then I'll be alerted, and we'll let you ask your question. Otherwise, let's continue with today's session. So that's what I wanted you to know from the previous sessions, and a little deep dive into it, and then we can continue with today. So today's class, as we said, it's on classes, objects, constructors, and modifiers. And this happens to be an introduction to object-oriented programming, OOP for short. Object-oriented programming, the first thing you need to know is it's a programming paradigm. Programming paradigms, there are multiple programming paradigms out there. There's functional programming, there's procedural programming, there's imperative programming, and many others. Object-oriented programming happens to be one of these programming paradigms, and we are going to focus on object-oriented programming for this class. Not everything about object-oriented programming, just the intro to it. Okay. So object-oriented programming actually, it provides a means of structuring your programs so that properties and behaviors are bundled together as individual objects. These objects contain data in the form of fields, also called attributes or properties, and also code, which are in the form of procedures, and procedures are also called methods or functions or subroutines. Basically, all this is saying is when you write code in object-oriented programming, when you are writing your program, OOP provides a means for you to actually structure your program so that the properties, which happen to be the data your program is going to work with, okay? And you know from previous sessions that this data, we keep them in variables. So basically the property is, you can call the property a variable, okay? A member variable. So the properties happen to be the variables, which are also called the attributes or the properties, and also the behaviors, and that's the procedures or the functions your program is going to perform. These functions can also be called methods or subroutines. So object-oriented programming provides you a means of structuring your program so that these properties, that's the variables, the data you're working with, and also the functions your code has to perform, these two components, it provides a means for you to bring them together into one individual object, and then you can go on and use that one object wherever you want to use, wherever it's needed. That's the core principle behind object-oriented programming. Okay, and there are diverse OOP languages out there. There are so many, but most of them, the most popular ones are based on what we call classes. It's based on the concept of a class. We'll get to know what a class is later. And what this means is objects are instances of classes, which also determine their type. This may sound vague, but I'll explain it later. Let me even explain now. Okay, so Like I said, the most popular programming languages, object-oriented programming languages, are based on the concept of classes. And a class is basically a data type. We'll get to actually details in the next slide. Objects are instances of classes, and then the class will determine the type of that object. Let's take the previous example we saw with a string s equal to hello world. The s is an object, okay, and its type is the string. So translating that into this scenario, when you create an instance of a class, that instance is an object, and then the class is the type. So the class doesn't only provide you the structure of your program. It doesn't only it's not just the properties and then the behaviors, but it also specifies. It determines the type of the object you are going to be creating. Okay, we will get into details later. So if you don't understand, you will get it. Don't worry. And all the object-oriented programming languages we have come to know are I think they are divided into two. We have the class-based ones and we have the prototype-based ones, or instance-based. So an object-oriented programming language can be that class-based. It can be based on the concept of classes, which we're going to look at for this session, or it can be based on the concept of prototypes or instances. And we won't be looking at that for this session. For this session, we'll just focus on the classes. Okay. So examples are Java, C#, Kotlin, Python, C++, Swift, JavaScript, etc. There are so many others, okay? And all these are object-oriented programming languages. From the previous slide, we have come to discover two keywords, a class and an object. So let's get to know what these actually mean. A class is a blueprint for how an object may operate. It defines the data, that's the properties, and then the procedures for a given type or object. So as I was saying in the previous slide, object-oriented programming provides a means for you to structure your program into data, the properties, which is the data, and then the procedures, which are the functions. Okay, and the way it does that is through what we call a class, and the class is that blueprint based on which you can define your objects. Let's take a house and a building plan, for instance. Before you build the house, you develop a building plan, and on that plan, you detail every aspect of the house. So the contractor just picks the plan and they know exactly what to do, and they build your house exactly based on that plan. So that plan is the blueprint. Okay, that plan is the blueprint for the house, and then the house is the object. Do you get it? You can't live in the plan, but you can live in the house. So the house is the object. That's what you can actually use around in your code, and then the class defines defines what the house should look like. It defines the properties of the house and then the functions, okay, the procedures. So that's the concept of classes, and then an object. That's the classes of the concept. An object, as we've said, it's an instance of a particular data type. We have seen various instantiations of variables in previous sessions. When I write the code string name equal to John Doe, I have created a variable that's of type string, and the variable's name is name, and I've given it a value of John Doe. So this variable name here, it's basically an object. Okay, so variables are objects, and this object is of type string, and it has a value of John Doe. To the next one, I have a variable age, which is of type int, it's an integer, and a value of 25. So this age is an object whose type is an integer. Okay. And the next one, car, McLaren, equal to new car. Remember from the previous session, we saw that when you create a reference type, use the new keyword. So in this case, car is a reference type. It's a data type, okay? And a data type called car, just like we have string and we have int. There's car, except car does not exist by default. You have to create your car. We will get to all those later, but for this scenario, let's assume there's a data type called car, and I've created an instance of that car variable called McLaren, and I've assigned it a new instance of the car type. So car is the class, and then McLaren is the object, which is an instance of the car class. I hope it's clear. For example, an object could represent a particular person with attributes. including name, age, address, etc., and methods like walking, talking, breathing, and running. And the class would cover people in general. Okay, so we can have a class to represent people, and we can name that class a person. So we can have a person class. A person has certain properties, like their name, their age, address are specified here, their height, and all those things are properties of a person. And then they can have procedures. That's methods like walking, eating, sleeping, running. All these are procedures, functions a person can perform. So these two components come together to form the object. Okay, and then what specifies what defines what the object can look like is the class. So the class will be the blueprint, and it will have all these things, and based on that we can go and create a person object, and then we can use that object in our code. So there's a diagram trying to represent what a class is like. So there's a blueprint of a car. A car has attributes like its fuel, its max speed, its color, its the type of its tire. Is it 21 inches or 18 inches? All those things. Okay, so a car has all those attributes, and it has procedures, its functions it can perform. Like we can refuel the car, we can drive, we can accelerate, we can stop. Do you get it? These are all attributes. These are all methods of procedures, functions of the car, and then its attributes as well. There's a UML diagram. UML is Unified Modeling Language. You can go and read on those. It's not necessary though. Yeah. So there's a diagram representing the properties of a person, and then the functions or the procedures, the functions, methods of a person class. So a person class can be like this: name, age, height, and then the methods speak and eat. And for a car, we can have the brand, the model, the fuel level, the tank capacity, speed, and we can have these are the procedures, that's the functions. It can drive, we can fill up, we can accelerate, we can slow down. Okay, so this is the class. There's the diagram of the class, what the class will look like, and we can translate this particular diagram into code to form a class, and then based on that class we can create an instance, and that instance is an object of that class. I hope it's clear. So there's a sample Java code of what a person class can look like. Okay, and one thing is, when you're creating a class in most class-based object-oriented programming languages, when you're creating a class, you use the class keyword. So the class keyword followed by the name you want to give to your class, and then inside the body you can define the properties and then the procedures. Okay, don't worry about the public keyword that here, we will treat that in a bit. So a person class can have a name which is of type string. It can have a person can have age, which is an integer. Okay, and we can have a person's height, and that's double. And the person can perform a function of walking. A person can eat. A person can speak. So this walk, eat, and speak are the procedures or the functions or methods or subroutines. And then the name, the age, and the height are the properties that a person can possess. Okay, so this is what a class would look like in Java, and even some other language. You can take this particular code and put it in some other language like C#, and there will be no error. It will be the same thing. Okay. So there's also another example, a sample class for a car in Java. So like I said, you define a class by using the class keyword followed by the name you want to give to your class, and then inside the body you define the properties of your car and then the functions. So a car can have all these properties and it can perform all these functions. Okay, and this will be the blueprints based on which you can create your car objects and then use your car objects. So let's take a look at what this would look like in code. I hope it's clear so far and you can all hear me. Not getting any feedback, it feels a bit weird. So
oh, we can hear you.
Yeah, we can see and hear.
Okay, and it's not vague. So far everything is okay.
Yes.
Okay, we thank God. So there's a sample Java code of a person class. So like I said, we use a class keyword to define what a class should be, followed by the name you want to give to your class, then the properties. You can have as many properties as you want, as the blueprint you are trying to define requires. Okay, so I can add as many as a person requires here, and a person can perform not just these 3 functions, but many others. We can add all of those here. Okay, but for just this example's sake, yeah, let's take it as this is all a person can do. So we have all these, and yeah, so now there's the blueprint that defines what a person should be, and based on this blueprint, we can create instances. Those instances are called objects, and we can use those objects in our code. So let's see what that looks like. To do that, like we know how to create variables already. Let's take an example. We have string, let's say string name equal to John Doe. Okay, we have seen things like this in previous sessions. We know that's how we create variables. The name, so it's the type you want to give to your variable, followed by the variable name. Then if you want to assign a value to it, the equal sign, sorry, the assignation sign, and then the name and the value you want to give to your variable. Okay, so this the pattern we follow to create our variables. So to create,
yeah, please, I can't see your screen.
you can't see my screen.
Yes.
Can anyone else see my screen?
No, please, we do not see your screen.
Oh, okay,
No,
sorry.
I can't see.
James, when it usually happens that like this, you just stop sharing your screen and you share it again.
Yeah, thank you. I think I'm sharing just my slides, and I switched to a different screen. That's why it happened that way. So let me share the screen.
I think it's too small.
Yeah, I'm coming. Give me. I think my destiny is frozen a bit. Okay. Oh, come on. I'm coming now, please. Can you see my screen now? Can you see my code?
Yes.
Okay, good.
Yeah.
Okay, so I think I have to start again then. So let's take a person class, for instance. Let me undo everything I've done here. That's what a person class would look like in Java. Okay, the class keyword followed by the name you want to give to your class. Then inside the body, you define the properties a person can have, and then you define the functions a person can perform. Okay, so this is the blueprint, and that's what we call the class. Based on this class, we can create instances. Those instances are what we call objects, and we can use those objects in our code to interact with the person. So like we have come to see, to create a variable, it's the type followed by the variable name and then the value. That's if you want to create and assign at the same time. So let's say I create a variable of type string and I give it a value John Doe. So the format is the type, the variable name, and then the value. Okay, so that's how we know variables are created. So following this particular format, let's try and create a variable of type person. So the type will come first. Our type is a person. We want to create a person object. So person, then followed by the name we want to give to our person objects. So let's say I name it just person. Okay, well, let me give it a name. Let's say John. So I name my variable John. I want to give it a value. We saw from the previous slides that a class is a reference type. And reference types, we instantiate them using the new keyword followed by the class you want to instantiate. Okay, so it's the same principle as what we have here. Like we also saw, string can be rewritten as let's say another name. I can write new string. Okay, other name. Okay, because string is also a reference type, so I can either create it this way, which is a shortcut to create strings, or we can follow the full way to create a string, which is this string name, then you use the new keyword followed by the string constructor, then you put your value inside of it. Okay, so we can do this. That's how this is how reference types are created. So since a class is a reference type, this is how we have to create it. So person, the type followed by the name of the variable. Then if we want to assign the assignation sign, then the new keyword, then the instance. Okay, so now we have our person object created, and like we saw, the person is the class, and then the variable we have created is the object. We said an object is an instance of a data type. Okay, a class is a data type. So this object, this here is an object, this variable is an object. So all variables are basically objects. So let's see how we can use this class, this person class. I have this class called John, this object called John. We see all the properties we defined for him, and then the procedures it has as well. Eat, I think there's some default ones in there, but don't worry about those. We have the eat and we have the speak. Okay, so these are all things the person can do. So how do you use them then? These are like they are just variables. How do I access these variables? We use the accessor operator, which is the dot. So the dot, and then I can access whatever I want to access. Then I can give this a value. Let's say John's age is 24, 25. Okay, so like we have seen in variables, I can have name equal to John Doe. I can give it another, I can change its value along the line and say he's equal to James. Okay, so it's the same thing here. John, but because this is a class and the age property exists inside of it, I have to access it using the accessor operator, which is the dot. I hope it's clear. So I can give him a name. I can give him, I can assign a value to it, to his name as well. Let's say I call him John Doe. Okay, let's say his height. He's 170 centimeters tall. You see, so that's how that's how you can access those fields, those properties within the class through its objects, through the object instance you have created. So let's try to print some of these to screen. So let's print his name, John.name. Let me write name is something like that. Okay. Yes. Yeah, let's just write his age. Okay, I hope I'm not confusing anyone. So if we run this code, when we run this code, let me get rid of all of these. We don't need these ones. When we run this code, the person class, an instance of it will be created and stored in John, in this object, this variable John. And then we change the age, we set the age of John to 25. We set the name to John Doe. We set the height to 170. And then we print out my name is, and then his name to screen. Then we print out the age as well. So that's what we expect to see. So let's try that and see. I hope the text is not small. It's huge enough for you to see. Or should I increase the size?
Yes, if it is possible.
Okay, so you see the results. To increase the size a bit, I think it's a bit okay now. So as you can see, as we expected, it prints my name is John Doe, which is the name, the value assigned to his name property, and we printed that name. Let me put a space here. no problem. And we print his age as well. I am 25 years old. Okay, so that's how we can access the properties, that's the fields, the member variables of the class through the object instance we have created. Is it clear so far? If there are any questions, you can ask them. If not, let's continue. Let's see. We also have a class here. Yeah. So a car class over here. So a car can have all of these properties. Like I said, to create a class, the class keyword followed by the name. Within the body, you can specify the properties of what that class can have, and then the functions it can perform, the procedures. Okay. So a car has a brand, a model, floor level, all of these things, and then yeah, you can drive, reverse, accelerate, slow down, you can fill up. Okay, so these are things a car can perform. This is a blueprint of our hypothetical car is. So let's go on and use this car as well. Let me comment all of these guys. So like we said, to create an instance of anything, the type comes first. So our car. And then for instance, we want to give it to our car. Let's say let's say BMW. And then the new keyword, then this way. Then we have created an object of type car. So like we did with the person,
Hi,
we can
James. Hi,
change.
James.
Okay, hello.
Yes, can you increase your text more? Like, can you increase your text editor? Maybe Control Plus to zoom it a little bit.
Is it okay now? I've increased it.
Yeah,
But it's not showing at your end.
yeah, it's better now. It was a bit
Okay.
far away. Yeah.
Oh, okay. Thank you. So, like we did with the person class, we can change the properties of this object instance we have created. To do that, be the object, then the accessor operator, then you can set. So any for model of BMW are there. I don't know of any BMW. So okay, let's say there's the M4, so something like that. So we can have this, and then we can set the other properties. Brand, it's a BMW, and we can set as all the properties we want. Let's say currently the car is traveling at say 60 kilometers per hour, and then its top speed. Remember, all these things I'm accessing exist within the class, the blueprint. Okay, all those things I'm accessing exist within it. If it doesn't exist there, you can't access it, because yeah, it doesn't exist. Okay, so if you're trying to access it and you are getting errors, it probably doesn't exist. So go and create it. Do you get it? Okay. So let's say it has a top speed of 200 kilometers. So like we do with the person class, we can print these as well. We can print top speed. And then I think with the person class, I didn't call its functions. So like we are accessing the properties, we can also access the procedures, the methods in there. Okay, so I can call accelerate, I can call slow down. Okay, I can call fill up. And when I run this, it creates a car. It creates a car object. So it creates a variable that's of type car, assigns it to a car object, and then we assign to the model property of our object M4. We assign to the brand property of our object BMW, and yeah, and the rest. And then we print out the top speed, and we also call its accelerate function. So we are asking it to accelerate, we are asking it to slow down here, and we are asking it to fill up. So let's see what that results in. So as we expect, we printed its top speed, and it's print it, yeah, so we have that here. the top speed. The accelerate, what it does is it just prints I feel the need for speed onto screen. So that's what we have here. I feel the need for speed. And then we called the slow down. Slow down prints too fast for you, slowing down. So we have that here as well. Okay. And then we also called the fill up. And fill up, all it does is it also prints filling, thankful. And we have that here. Okay. So imagine one of this class is something let's say you are trying to log in or something, so you can have a login method in some hypothetical class, and when you call that, it will just go through the code you have written to log a person in, and then it will do that, and then you are logged in. So that's how it all works. This is just to get you to understand what all of this is in practical applications. This is the same thing you'll be doing, except instead of just printing things, you'll be writing real code in there to actually perform some functionality. Okay. So yeah, that's a class. It's a blueprint, as we have seen, and it has properties or procedures, and based on that you can create objects, which is just an instance of the class you want to, which is just an instance of the class. So let's continue. If you have any question, please you can ask. Okay, going back to our slides. I hope you can see my slides. Okay.
Yes.
So now that we have familiarized, okay, thank you. Okay. Now that we have familiarized ourselves with what a class is and what an object is, let's go on to what we call a constructor. A constructor. Okay. A constructor is a special subroutine. We know a subroutine is just another name for a method or a function or a procedure. Okay. So a constructor is just a special function within a class, which, when called, it creates an object of the particular class in which that constructor is defined. Okay. The constructor prepares the new object for use, often accepting arguments. I will talk about what that is in a bit. It often accepts what we call arguments that it uses to set the required members, the required member variables of your class. If you don't get anything, don't worry. When we get to the code part, it will be clear for you. In most class-based object-oriented programming languages, the constructor has the same name as its class. Okay, so if your class is called a person class, like we saw, the class name is person, its constructor will also have a name called person. Do you get it? So the car class, its constructor will also have the name car, and any other thing. Let's say there's a class, you have a class called house. Its constructor will also be called house. Okay. Yeah, this will make sense in a bit, don't worry. So this is what a constructor looks like. Take our person class, for instance. These are the properties of our person class: the name, the age, and the height. And its constructor has the same name as our class. It's a function, it's a method. That's why it has the same signature as the walk and the rest we saw in there. So this what it will look like. Again, don't worry about the public keyword. We will discuss what all those are before this lecture ends. So class person, and then it has a constructor with the same name person, and within its body we set, usually within the constructor's body, that is where you prepare the class for use. Okay, so you set the initial values for the member variables, so you can go on and use them within your code. Do you get it? So when you, in the previous example, when we created it, we didn't even have a constructor, so nothing happened. It just created a raw instance, and everything was set to their default values. So that's why we had to set values to them within our code before we were able to, and then we went on to use those values. But when you create an instance of a class, you can let the constructor do some work of constructing, like its name suggests. It's a constructor. It constructs whatever class it exists in. So when I want to create an instance of person, when we call the new person, what it did was it called a person constructor. Okay, let me switch to code to make it a bit. Let me go through this first. Yeah, so the constructor will set the default values. If you have any, it will set those values for the member variables, and then you can use that in the code through the object you have created. That's where a car constructor will also look like. We have our car class. These are the properties, and then its constructor also has the same name as the class itself, and within its body we can set the initial values for the properties within the class. Okay, and we can do any other thing we want to do as well, but usually we just set the values, and any initial function you want to run, you can do that as well. Let me go to the code and demonstrate it for you for better understanding. Okay, I hope you can see my code. Let's take our person class, which we saw from the previous session. Again, a class is defined by the class keyword, then the name, and within it you define its properties and its procedures. So our class has these properties, these which are also called member variables or fields or attributes. Okay, so it also has the functions we saw earlier, the walk, the eat, and then the speak. And now we have introduced other things. Don't worry about this bit, I'll come to this later. Just focus on this for now. So there's a constructor we have created for our person class. And this person constructor, when we create an instance of our person class and we create it using this constructor, what it does is it will do whatever it is we have specified within its body. It will do that. So in this case, what we are doing here is we are giving a value to the name property of our class. We are setting it to Kuntu Langston. We are setting the age of this person class which we are creating. That particular instance we are creating at that point in time. We are setting the name to Kuntu Langston, the age to 78, the height to 170 centimeters. Okay. Now you may be wondering what a this keyword means. The this keyword is just referring to the particular object we are inside right now. As it stands now, we are inside this thing. We are inside class. So this here is just referencing the class. I hope it's not confusing. Yeah. So this keyword here is just referencing the object we find ourselves inside right now. So in this case, we are inside this class. So this here is just referring to the class. So this, like we saw in the previous code, when we were accessing the name, we use the instance we had dot name, the instance dot age, the instance dot height. So that's a similar thing we are doing here. The class which is this dot the name, then dot age dot height. In other languages, instead of this, they use self. Okay. Other languages have their own ways of doing things, but for Java it uses this, and most other languages also use this. Yeah, so that's what your constructor does. Now let's see a sample usage. Before that, let's see the car. So a car class 2 has the same thing. Its constructor sets the default values for our models, for our member variables, our properties, setting all these things for it. So let's see how we can use this. Like we did in the previous class, in the previous example, let's create a person object. Let's name this person. Let's just call it person. New person. So what it's doing here is when we call this new, it calls the constructor we have created within the class. And then it will run whatever is in here. And this here is just what it does is it's creating like its name suggests, it's a constructor. So it's creating an instance of the class we are inside, and it will return that instance to whatever variable we are creating. I hope it's clear. You may ask why did the previous example we saw work when there was no constructor declared? If you notice, there was no constructor declared in the previous one, so why did it work then? What happens is most programming languages by default, when you create a class and you don't create a constructor, you don't write code for a constructor within it, it creates a default constructor behind the scenes for you. So that's what we used. But the moment you create your own constructor, it's the compiler will not generate the default constructor for you because you have created your own. Do you get it? So now that we have created our own constructor, it's our constructor that will get called because now the code won't generate the default one for us. I hope you get it. So this constructor here is referring to the very one we have created, and this very one we have created, when we call it, it will run this block of code. It will set these particular values to our properties, and then it will return an instance of our person class and store that in our person variable. So we can go on straight and do some. Let's just do some basic printout. Is someone speaking? Okay, so let's just go on and print the person's name, and let's print the person's sorry. Yeah, let's print their name, let's print their age, let's print their height. While we are at it, let's just call some of the methods on the person class. So let's say person dot walk, person dot eat. So see the difference between what we have here and what we had in the previous one. The previous one, we had to set the value for the person's name and the rest to some John Doe. Okay, let's just say John for now. The previous example, we had to do this because we didn't have a constructor that was setting the values for us. We did this ourselves. So we could go on and reference that value later. Okay, but this time around, the constructor is doing that job. The constructor is doing this job for us, and that's exactly what we have in here. The constructor is setting those values for us, so we don't have to come and do it here ourselves. Do you get it? So when I print this, I'll guess the value. We will guess the values we have set for these particular fields within the constructor. Let's see if that's what will happen. As expected, it prints the name, the person's name, which you know to be Kuntu Blankson. Okay, and then when we print the age, we get 78, which is exactly what we have here for the age. And we print the height, we get 170, which is exactly what we have set here for the person's height. Do you get it? So let's say within the constructor, I decide to print something. Say I print class created. Let me say instance of person class created. So you see that also gets printed to the screen when we run this code. That will actually get printed before you. Let's see how that happens. Okay, so you see we have that particular print statement executed first, because what happens is when this code runs, it's running from top to the bottom, and the first thing it encounters is this: we are creating a new instance of our person class, and like we said, this person is just an invocation of the constructor we have within our person class, and that invocation has a body, and what that body is doing is it's assigning this, assigning that, and after assigning all those things, it does this print. It prints instance of person class created. So after printing that, then we move on to the next line, which then we go on and print the person's name, the age, and the height, and then we walk and we eat. Do you see? So that's the order in which all this got executed. The constructor body got executed first, assigning the fields, and then printing this guy, and then the rest of our program ran, printing all of these, and then invoking these functions on our person object. I hope it's clear. That notwithstanding, we can go on ahead and change some of the values. of our person object. So let's say I change his age to 29, and then I do another print. Say new age. Person.age. Okay, as usual, we get our instance of person class created. We print the name, we print the age, and then we print the height, which is 170. And then the next code changes the age to 29, and then we print that new age, and that's printed for us, new age 29. Then they move, which just prints remove, gets run, and then it prints it. And then they eat, which just prints Jammy, also gets run, and then it prints it Jammy. So I hope it's clear so far. If the other tutors have anything, you can just let me know, and then you can chip in. So that's okay, Andy.
Yes, so I'm also just going to explain a little with what you said in the real world. So in the real world, like a class can be called a human, and we all know human have head, hands, legs. These are the attributes of a human, and the functions or the methods, the actions that a human can do is to talk, walk, sing, dance, and all that. So if we want to create an object, we can create me, Andy. I am an object of the class human. So when we are categorizing me and your tutor James in one class, we are under humans. But then we all have our attributes and our functions. And we are individual objects, separate objects that we can perform different so for instance, the human has a name. So if you take me as an object and you take my name is Andy. But when you take James' name, his name is how do you call it, James. So we are the objects of the class. We are the class is the blueprint of us, but then we are the real how do you call it, the physical side of the class. So the class is just a template which is used in creating a lot of objects. So all of us here are objects of the class called humans. So when we are grouping all of us, we'll be grouped under humans. The same way when you do animals, do the same thing, you group them under animals. So we have cats, we have dog, we have pig, we have snake, but we group them all under animals, and they all have their various unique attributes and actions. So that's a little I'll add to what our boss James just did, and I think he's just replicating what I just explained right now. Yes. So if you have any question, you can also ask, and then we also have one of our tutors in here, Amos, and I think Alvin. Yes. So okay, so we have a raised hands. Peter Bedu. You can unmute yourself and talk.
Yes, please, can we also look at it like the class having the object, as you said, as a human being, and then having the descriptives of the human being, how you describe the human being, and then the function that the human being can also perform.
I don't quite get your question. Can you please come again?
I said, can we look at the class as something having the object, and then what the description of that object and the function that object can also perform as being the three things combining to form the class?
No. I think let me go over the class.
Yes, James, make the something
okay.
hands. Make the something hand, and the
Hand,
hand
okay.
can be, yes. Yeah. And
So yeah, this person let me just say hand. That's okay. Okay, so
go ahead.
in trying to address the question, look at the classes this way. First of all, in the real world, we don't have classes. We have classes, but they are implicit. They are intrinsic. Like you won't see a class here, class. You would rather see objects. Okay, you see a human being, and that human being has all the values. Let's say you, for instance, you are a person. Okay, you are an object in the real world. You have a name, you have an age, and all of those things. Okay, all these features of a person can have. You have all of those things. So if I want to represent, but you're not the only person that exists in the world. Okay, there are so many other persons. All these persons have all these properties and all these actions they can perform. Okay, so what we do is, if I want to represent you, the best way is to just create a general blueprint of what a person can be. Do you get it? So, and that general blueprint is what we call the class. So that class will define the properties of a person and then the actions that person can perform. And then the instances of the class are the real human beings in the world. So I don't know what your name, but I saw PB or so something. So let's assume that's the initials of your name. Yeah, I think that's the initials of your name. Okay. So in the real world, I have a person class. Sorry, no, I have a person class, and in the real world, there are instances of that person class, like PB, like me, James, like Andy, and so many others. Okay, so these are all instances, and these are objects. These are the objects. The class is just the blueprint that's defining what we can be like. I hope it's clear.
Yes. And to add to what James just explained, James, can you make the hand an int? So you see, there are some human beings with just one
An
hand
int.
because they are deformed. Yes, they are deformed. So, but then at the end of the day, when we are categorizing them, we'll categorize them under humans. Yes. So
Oh, I've
if
changed it to hand.
yeah, yeah. So just use this to make your example, and I think maybe they will understand better. Yes. Peter Beidou, if you still have a question or a contribution, yeah, the floor is for you.
Yes, I'm okay. So does that mean that if you specify the class and
Okay.
someone does not have some of the features in the class, and you call that class, will it reject that person? Because if you specify that maybe the description of this object is the person must have a hand, a head, a leg, and the person must be able to, let's say, talk. And when you have a dump, will it recognize that person in that class?
Okay, so let me answer this. So that is why we even have the what he's explained as constructors. There are some classes when you are defining them, their objects, there should be some of them their attributes have to be like present. So for instance, every living human being has a head. So if you are declaring, maybe if the class has a property called head, it will definitely have the value already defined in it before the object is already created. But there are some attributes that the person or the object can live without. So for instance, we have human beings on earth that have no arms. Some to have just one arm, and some to have even three arms by mistake. So with that one, the class will allow you to define them. Do you understand?
Okay.
I don't know if I've explained what, maybe James can take over and
Yes,
say more.
okay. I'm okay.
Right.
Okay,
All
so
right.
adding to what Andy said, remember, like I said, the class is not this concrete thing that exists. It's just the blueprint, and you are the one writing that blueprint. So you will have to factor what exists in the real world, what can be, what cannot be, and based on those things, you will create the class so that it satisfies all of those things. Do you get it?
Okay.
Yeah, thank you. So that's it. That's the basis of a constructor. Let's move on to the next phase of um um the next slide. Come in. You can see my slides, I hope. I hope you can see my slides.
Yes, we can see. Continue.
Okay. Okay. So now we have seen what a constructor is, what it does. Now let's look at other types of constructors. The particular type of constructor I want us to look like is I want us to look at is what we call the parameterized constructor. So you saw in the previous example, the constructor is what actually creates the instance of our class, and then within it sets the initial values of all the attributes of the class. Okay, but you saw that in the example we set some default values. Like every time I create a person class in our example, it will always have that particular name I had coded in there. But what if not every human being in this world, not every person in this world has that name? Everyone has their own name. So we want to be able to make that dynamic so that that name will be different. That name can be different for every instance of a person we create. To do that, you have to pass the person's name and all those attributes of the person through the constructor. You can create a constructor to allow that, and that's what we call a parameterized constructor. Reading from the slide, constructors a constructor that can take one or more arguments, we call them parameterized constructors. When an object is declared in a parameterized constructor, the initial values of the class members have to be passed as arguments. We'll say that in code in NGP, and it will make it clear to you. Have to be passed as arguments to the constructor's function. Let's go into the code first, and then I'll come back to this next line. Let me. Okay. So yeah, still constructors. Sorry. Now let's tackle this other constructor we have here. Okay, like we said, the constructor always has the same name as the class it exists within. This constructor is what we call a parameterized constructor. Don't worry about this. Let me actually remove this so it doesn't confuse you. There's another constructor of our person class. Okay, this constructor is defined to accept certain things we call it is defined to accept arguments. And the way you define those is by making it is by giving it parameters. These variables, we know these are variables, right? String name, int age, double height, these are variables. These variables we are given to our person constructor here. They are what we call parameters. Okay, that's why we call these constructors parameterized constructors, in that they take arguments for the various parameters that they are expecting. I hope it's not confusing. Yeah, so a person, whenever we create a person, we can either use this one constructor which doesn't accept any arguments. We know it doesn't accept any arguments because within its parentheses there's nothing. We know this constructor accepts arguments because within its parentheses we have specified some parameters. That's specifically we said it should accept a name, it should accept an age, it should accept a height as well. And then what we do is within its body we assign whatever value you pass to this constructor when you call it. We will assign those values we use those values as the default values for our properties. Over here we hard coded the name, so every time you create a person, the person will always have the same name, will always have the same age, the same height, but that's not what it is like in the real world. So for it to reflect the real world, your constructor has to accept these arguments, and it will assign the values passed as those arguments that have been passed to the properties of the class. So in this case, whatever we will pass as the name is what it will assign to the name field. Whatever we pass as the age is what it will assign to our age property. Okay, whatever we pass as the height is what it will assign, rather than hard coding, which is not realistic. It will rather be dynamic, so that whatever we pass is what it will be. So let's go on and use this constructor and see. Let me print something here as well and see. parameterized code. Okay, that's good. Let's go on and use this particular constructor. Let me get rid of all of this. Let me keep this. And instead of using that constructor which doesn't accept any parameters, we can use the second one, which we know accepts a name, right? So let's give the person a name, say Andy. Then we know it accepts an age. Let's say the age is 27. Okay, and we also know it accepts a height. And the height is okay. So let's say 180 centimeters tall. Okay, so with the parameterized constructors, because we have defined that it should accept parameters, when we use it to create an instance, we have to pass the values of those parameters, which are called arguments. Okay, what we have defined here, the variables are called parameters. The values we pass when we are creating an instance are called arguments. Okay, so when we create a person, an instance of a person, class using the parameterized constructor, we pass the various arguments for the values it's expecting. Okay, so it's expecting a name, we are passing that. It's expecting an age, we are passing that. It's expecting a height, we are passing all of those. So when we run and we print all of these, let me comment this guy out. When we run the rest of this code, and we print person.name, it will print what we passed here. It will print the age we passed here. It will print the height we passed here. Do you get it? So let's see if that's what will actually happen. Let me get rid of this as well. Yeah, so as expected, the code runs from top to the bottom. The first line of code here creates an instance, creates an object, which is an instance. It creates an object for our person class. And that's the constructor it's using is expecting name. Is expecting name to be passed, age, and then height to be passed. And we are passing all of those three things to that constructor. And that constructor is within its body, it assigns the name we pass to our name property up here. It assigns the age we pass to our age property up here. It assigns the height we pass to the height property up here. And then it goes on to this next line and it prints this to the screen. And then that code is now done executing. So we come back into this block, and then the next line of code prints the name. So as we expected, this guy, after the assignations, the printed parameterized constructor has been called, and then this code runs and we print the name. As expected, we get Andy. We print the age. As expected, we get 27. We print the height, and as expected, we get 180. And then the methods walk and move also print their respective, they perform their respective actions. Any questions? I hope it's not confusing and it's clear. Okay, so let's take a look at our car as well. Our car also has, we have a similar one for our car object, our car class. It has another constructor which accepts values, which accepts arguments for all the properties we have defined up here. And as it happened with the person class, whatever values, whatever arguments we pass here for these parameters, those values are assigned to the various properties. And then at runtime, we can print those. So let's create let me create a person, a car class. So let's say this is just car, new keyword. Then we call the constructor. In this case, we are calling the constructor that's accepting the arguments. Okay, it expects that we pass a brand. So let's say the brand, as we're using as other example, the brand is BMW. It's expecting a model. Let's say the BMW is M4, as we use the other one. Let's say its full level is I think that's also a string or an integer. The full level is a double. Okay. Let's say its full level is say 4 liters or something. Its tank capacity, let's say its total tank capacity is 6. it's currently traveling at 60 kilometers an hour, and its top speed is 200 kilometers an hour. Okay, so remember those things we passed all of them because the constructor is expecting that we pass all those things. It's expecting a brand, a model. Yeah, hello, Andy.
Hi, James. We have roughly
Yeah.
some minutes to wrap up. I was just telling you behind.
Oh, okay. Okay, let me rush through the rest then.
Yes.
Okay,
Thank
so
you.
just like it happened with the person, class, the same thing happens with the car. So when I run this, I can print out the car's model. Let's print out and a few other things. Let's print out its top speed. Let's print its 4 level. Okay, so as expected, starting from the M4 parts. Remember, we printed the car's model first, which is M4, the brand BMW, the top speed 200, and it's 4 level 4. Okay, so that's how it works. Whenever we want to set dynamic values, you make sure that you are passing those values as arguments to a constructor, and the constructor will assign those arguments to the properties, and then you can go on ahead and use them within your code. Continuing. Coming. Okay. Now we have this. We have seen parameterized constructors, and also a class can have more than one constructor, as we have seen. We had 2 constructors in our various classes. One didn't accept any arguments. The other accepted arguments for all the properties. We have something we call constructor overloading. We can have constructors that will accept maybe just 1 or 2 of some of the properties, of some of those arguments, or one that will accept everything, just like the ones we had. The ones we had were accepting values for all of them. You can have some that will maybe accept just the name and the age, but not the height. And so over here, you can just set a default value for the height. Do you get it? Yeah. So that's constructor overloading. You look in subsequent sessions. We will look into details for some of these things. The next and the last bit to look at is what we call modifiers. Let me rush through these ones. Modifiers are just special keywords, okay, and they let us fine-tune the access to the members of our class and even the class itself. It helps us control which of the objects within our class we can have access to. Okay, it helps us give control which members of our class or even the class itself that can be inherited or not. If you are reading the slides, you can see inherited, override, and all these things. Don't worry about those. The next section, also the next 2 sessions, we will talk about those ones. So don't worry. For now, just focus on just the first part, the access part. Who can access the class or who can access the properties within our class. Okay, let's go straight into code and walk through these ones. So now with access modifiers, there are 2 types of access modifiers. Sorry, with the modifiers, there are 2 types. You have access modifiers, and we have the what's it called? The non-access modifiers. Okay, access modifiers, as their name suggests, they help you access the class or the properties within the class. Okay, so one example of access modifiers is public. There's private and there's protected. Those are the 3 main access modifiers: private, public, and protected. Public, as the name suggests, it's public. It means that this person, we have decorated it as public, which means we can access this person class anywhere within our code. Okay, we can access this person class anywhere within our code. If I made this private, which is actually not possible, you cannot make a class private. It's giving me a warning. You can't make a class private. There's an exception to that rule though, but don't worry about that for now. So when I make a class public, it means wherever I am within my program, I can have access to that particular class, and I can create an instance of it and use it like we have seen so far. Okay, not just the class, the properties within the class as well. I can make those public as well, or even private. Let's say I make the age private, and I make the height to private. Okay, so all this is saying is when I create an instance of this person class, I can have access to the name. Why? Because it is public. Okay, so access modifiers help us. They just control how they control the access, who can access the class or the properties or the methods inside of it. Okay, so that's what access modifiers do. We have public, we have private, and we have protected. Let's say I make this one protected. Okay, now let's go to the code and see something. Let's create an instance of our person class, person, the default constructor. Okay, now let's see, like we know the accessor, we can access using the accessor operator, the dot. I can access this this name. Let's say I print person dot name. Like, pardon?
Tripod. Tripod or 712. And
Okay,
I've
so-
never said going as it.
Okay, so
Sorry, James.
as we saw in the person class, I made the name public, which means I can have access to the name wherever I create an instance of this person class. I can have access to the name. I made the age private, which means I cannot have access to it. It's private. Okay, like the name says, I can only when you define something as private, it means you can have access to it only within the context within which it is created. So this age property is created within the person class, so it will always be private within the person class. That's the only place where it will be visible. Outside of this class, it won't be visible. You can't have access to it. Okay, so you see the age is giving me error here. It's saying age is not visible. Do you get it? So that's what private does. What about protected? Let's print out let's try to access the height. I made the height protected, so you see the height is also not visible. What protected does is it only makes protected works in a way like private. It also makes it private, but then it makes it public for the package within which, well, I've introduced another keyword. It makes it public for the package within which that particular class exists. Now think of a package as a folder. Okay, this person class here exists within a package called modifiers, which is just an ordinary folder. Okay, it's a folder, and inside that folder I have a person class. So if I make a field in this person class protected, it will be public. Okay, it will be public, but public for only this class, and then anyone who inherits from this class. Don't worry about inheritance, we'll talk about it later. So I think I should probably I probably shouldn't talk about protected. You understand it then. So for now, let's just take private and public. Let's make everything private so I can move on to the next session. That's the last bit. Now, as you have seen, if I make something private, I can't have access to it anywhere except within the class. So in that case, how will I have access and then work with the fields? Because everything is now red. How will I have access? That's where what we call getters and setters come in. Getters and setters are special functions within a class that
James.
expose.
Hello,
Pardon?
James.
Yeah,
Yeah.
hello. Time is up.
Time is up, but I would like to ask our boss, Amonkwa, if we can have
Okay.
part of this class because we understand also that time is of essence. Plus, if piling it up on them, maybe they might not understand. So,
Yeah.
since Amankwa is, can we agree to have part two of this class, or we are going according to the schedule or the plan of this course? Okay, so let's give you 10 minutes to wrap up. I hope 10
Wrap
minutes
up.
will be enough.
Yeah,
And we
10 minutes is
apologize
more than
for
enough.
us keeping that long. We already came in late, so let's take our 10 minutes back. So
Okay.
over to you, James.
Thank you. So yeah, this brings us to the last bit of this whole thing. When you make something private, we still have to use it. Okay, we still have to access the person's name when we create an object. When we create a person object, we still have to use their name to do other things and their age and their height and all those properties. So the way we can access them is through what we call getters and setters. Like their names suggest, one is a getter, the other is a setter. A getter is what will get the property and then return it to whoever is trying to access it. And through the setter, you can change its values. So let me just give an example. So I can have I can create a get name function. Okay, so it's an ordinary function like what we have with the walk and then the eat and the speak. Okay, it's an ordinary function. But what it does is it's public, unlike the property, the field, which is private, the getter and the setters, we make them public. So they can be visible outside of the class to anyone who can use the class. Do you get it? So get a getter. Let's say I create a getter for my name variable. I name it get name because what it does is it gets the name and returns it to whoever is asking for it. Okay, so that's a getter. And I can create a set name as well. Set name will accept a parameter like our constructor, which is accepting arguments for its parameters. The set name also accepts a value for our name. And what it will do is whatever value we pass, it will set that to our name property. So that's a getter and a setter. So you can create getters and setters for all the properties within your class that you want to expose. Do you get it? So in this case, let's say I want to expose all three. Then it means I have to create getters and setters for all the three of them. So now I've created a getter and a setter for our name. Let's create one more for our age. So I have a getter for my age, and I have a setter for my age. So we have the height now, the height left. So a getter for my height, and then a setter for my height. I hope it's not confusing. Understand it this way: whenever you make something private, but then you know that anyone who creates an instance of it has to get access to that thing you have made private, and that thing is a property, you have to create a getter and a setter for that property so that they can have access to it. And ideally, this is how you should write your code. When you create a class, it's best that you make all the properties private and you expose them through these getters and these setters. So now we can come here and correct these errors. If I want to get the name, there's a special function for that called the get name. So I call get name, and get name will return the name of the person. Do you get it? And get age will do the same. And get height will also return height. And now our error is fixed. Do you get it? So when you make it private, you expose them through getters and setters. So I can go on and run this code, and we will get the various. This one will print the default values we have set in our class because see the constructor. We didn't use the parameterized constructor. Okay, so the default values is what gets used, but we can use the other constructor and give it a name, and let's say an age of 30 and a height of 100, 190. No problem. Now when I print this, when I run this code, we get the same. We get the result we expect. It gets the name for us, which is Andy. it gets the age, and then it gets the height, and we print all of those things to the screen. So that's getters and setters in summary. Is there any question? I rushed through the last bit, so if you have any question, please you can raise your hands and I'll be alerted and you'll be asked to ask your question. And if the tutors have any addition to Andy Amankwa.
Since our boss is here, I'll leave. Okay, we have Malvin's hand up. So Malvin is also a tutor. So Malvin, you can mute yourself and
Yeah, hello.
hello, sir.
Boss.
Yes. Yeah, so I have one question to ask here. So with the parameterized constructor that you used, right? Let's say what if
Yeah.
you miss or you don't provide one of the values. Let's say you provided a name, you provided the age, and you left the rest. But then if you print them out, what's gonna show? Thank you.
Thank you. If the constructor you used, for instance, with our person class, we have two constructors in here. The first one does not take any parameters. So if you don't pass anything at all, this one will get called. And then the second constructor we have takes three things, which means if you call this constructor, you have to pass all the three. Okay. Because that's what this constructor is expecting. So you cannot call this particular constructor and pass just two and leave the other one. Your code will not even compile. So it won't run. It will give you an error and then you will have to fix it. However, that's where constructor overrides come in. I think I rushed over that one as well. We can have another constructor. Okay. And then instead of asking it to take all the three, we can just let it take only two. Then we will set the values. Then we Then we have to set the default value for a height because we are not accepting any height. So I can set the height to be 170, which is the average height of a human being though. Okay. So there's one way we can solve that with our code. If the height is not required that it has to be passed, you can create a constructor that doesn't accept that one, and you can set a default value for it over here in your code. So that's something you can do. I hope it answers your question.
Yes, it answers my question. Thank you very much.
Thank you too. There's one last thing, non-access modifiers. I don't know, the time is up. Maybe we will have to treat that a bit later. Unless you want us to continue. The time is up and we have one last thing, non-access modifiers.
Yes, our time is up. But if our students have any question, we have to clear it up before we end the call. So the floor is open. I know our time is up. It's fast spent. Exactly 9:10. But we are just giving 2 minutes for our students to ask any question. Unfortunately, today we've seen a lot of them drop off. I don't know why. But then we still have Michael Edu, Peter, Bay, Wedi, KB, and who again? Yeah, we have these three students here. So the floor is still open for just 2 minutes. Then we end the call. For now, too, if you still don't have any question, we are still online on both WhatsApp and the Skype. You can just send your questions and will be answered. James, I wish you just write some few tests and share it with them and get their feedback on the pages. Not now, but then a few questions based on the topic. Then we just get their feedback and see whether most of them were able to grasp it. If they weren't, maybe we can rearrange again and have this class or something. Yeah.
Okay.
Because object oriented is a bit complex. So I understand if some will not understand, but then I don't know why most of them left. You also find out. And our boss is in Amankwa, so if you have anything to say, we just have 1 minute more, then we end the class.
Yeah, hi. Yeah, where am I is a little bit noisy. So, what I would say is the other topics that we couldn't treat, we might probably have another session and you can go through with us as well. So that's it for me.
Okay, okay. So thank you, our teacher James, for your time and giving us such a good intuitive on object oriented and all that. I've also learned some few things from the class. And on that note, I'd like to end this call for this class. And we hope to see you in our next class on Monday. Have a good night.
Okay.
You too. Thank you so much.
All right. Bye bye.